Streamed. Nice. All right. Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, September 27th. Got a pretty sweet agenda today, starting off with a demo, and then we've got three potentially long form discussions. So I won't waste any time here in the beginning. But before we jump into everything here on the agenda, we actually have two new community members on the call, and I would love it if they gave an introduction. I already asked them if they were cool with it. No pressure. Marcelo, would you like to go first?
Hello, everyone. My name is Marcelo Lopez. I am Argentinian. I'm so sorry for my English. Maybe it's not the best, but I try to do my best. I working as a IT architect for many years here in Latin America in different countries like Argentina, Chile, Peru, Paraguay, Brazil, and Uruguay. I co-founded two new enterprise. One of them is an API manager software. Is working as in Kubernetes. Right now, I'm very interested about the WebAssembly and how to use the technology in new process. At the beginning, I just try to understand the technology. Nowadays, I try to do something with the technology, maybe in different concept or different architect or systems. I don't know what else. If you have any question about that, I can answer the questions.
That was perfect. Really just wanted to love hearing why people come around and what they're interested in and what their kind of background is. So yeah, really happy to have you here.
Yeah, and by the way, I am F1 fan. You know that. Thank you.
Yeah, Marcel and Bailey were talking shop about random F1 things here in the beginning.
All right, and then we have one other community member who's joining for the first time. And apologies, I don't know if that's your name or screen name, but if you want to go ahead, it's all you.
Hi, I'm Fun. I'm new here, so I would say a site reliability engineer. I've had experience working with Kubernetes, Docker, Redshift, and now I mostly work with AWS. I was in like a CNCF program and we spoke about wasmCloud a whole lot, and I got really curious about it. So that's what made me join it. Actually joined like maybe 2 weeks ago, but I've just been moving around on shore, and I learned that like Rust is the language that is like the foundational language. So I started learning Rust last week. So I'm still kind of like looking around to see what I can do with it or how I can help and stuff like that. Yeah.
Love it. I'm always kind of going back and forth on like what it would feel like to learn Rust for the first time through like the lens of wasmCloud. So I'm really interested to hear what you think. Fun. Thank you so much for doing an intro. All right. Well, Taylor, I think you've got the coveted demo slot, so take it away.
Woohoo! That's the thing we all covet every week. We really want that demo slot. Okay, so actually, no, I am excited to give the demo today. We're going to talk a little bit about wasmFills, where they're at, how things are going, yada yada yada, all that kind of stuff. So let's go ahead and share my screen. I'm going to share the whole screen today. Okay, so we have made some progress with wasmFills. In case you didn't see it in the Slack, if you're not a member of the Slack or whatever, we did get to a point where we have a working wasmFill example, and we're working off of that to actually make this something that everybody can use. So what is a wasmFill? A wasmFill is a term we came up with. It is not a real term that existed before we started using it, but now it is because we decided it was. The wasmFill is a thing that makes it so that you can use your actor components with any of the interfaces that are defined, especially custom interfaces. There's these common interfaces that everyone's working towards supporting and solidifying called wasmCloud. And those are your kind of like key, like we call like the 80% use case, right? You have like key value, you have HTTP stuff, you have, like just those kind of messaging services, those kind of like are the basic core things you'd expect to have. And we have those built into wasmCloud itself. But there's many times you're going to want to write custom contracts. That's something we've always supported inside of wasmCloud. So an example of one that I'm working on right now that maybe I'll get to show and demo in a month or two as long as I get time to work on the side is like a GPIO contract. So I could start programming in GPIO devices here. So anyway, there is some interesting things around that, but basically, as it currently stands, or as we're in the middle of transitioning, but the previous way of doing things inside of wasmCloud was that you would take a contract. Actually, I'll show you this inside of our examples repo. We'll just use Blobby because we love Blobby. Previously, what you had to do was you had specific generated interfaces that we use, plus this dependency on wasmbus RPC. And these things gave us the ability to do all these like detached dependencies and stuff. But what we had was these dependencies you had to have in for our platform. And we want to completely split that out and have this entirely component model based. So what it looks like now is so what it actually looks like now when you do this is everything is defined via WIT. And you'll see that there is nothing here that has anything to do with wasmCloud. So that's what we're going for. But to be able to do that, we have to have this WASI-fill. And so these WASI-fills generate different, these WASI-fills basically do all the thing that does the encoding the data to be sent along the wire and then decoding responses back for you automatically. So I just wanted to do that again because I think we have a bunch of new people in the community. I want to make sure we're on the same page before I demo what's going on, or it just makes no sense. So, and yes, thank you. Victor put some things in the chat, which hopefully we can send that into the live share as well, the live stream as well, about like what the old interfaces look like what the Smithy things look like. That's what it used to be. And yeah, so there's no more. You'll see there's no. Yortis had mentioned in the chat too. There's no prelude. There's no nothing. But what we needed to do was support custom contracts. So we've done that through what we call these WASI-fills. Now this WASI-fill example, I'll go ahead and link this in the chat so that we can send that out. This is an entirely, like I said, it is an artisanally crafted, organic, locally grown, hand harvested, hand picked, organic, clear, free range example of WASI-fills. So this is not something you're going to have to do all the time. And this was doing the proof of concept to show that it works. And basically, I'm going to actually show inside of wasmCloud. Forgot to pull this up. Luckily, I know where it's at. So I showed this diagram before in a previous one, so sorry for those who've been here before. This looks a little bit like a beautiful mind. I'm sorry, but the whole point of what we're saying here is that essentially to interact with a wasmCloud host, you have your WASI interfaces and you have to have the ability to call the host to do something and to receive a call from the host. And so these WASI-fills fill in these contracts for us. So if we have a contract called foo and a contract called bar, the WASI-fill satisfies these interfaces for us. And so you'll see this here because this is just taking messaging. Messaging is built into the platform. You not actually use it, but it makes a great example. And when we define this, this gets defined saying like, hey, I want to export this consumer interface that your code is going to call, and I'm going to change this call to a host. So like inside your actor, you'll see here, this wasmCloud is only because of the name of the contract, not because it's wasmCloud specific. And you'll see right here, I need to export something that handles a message, and I need to call something from a consumer called publish. So I'm going to try to publish a message in this case. So what this export does is says, I'm going to export all the methods for you to do it. And it takes the code and it exports out all the stuff for request, publish, and those kind of things, so that it does all the stuff for you. So you'll see that it's handling all the serialization and stuff that you'd expect from wasmCloud that wasmCloud was doing before in those libraries, but it's entirely external to your dependencies. So then what happens is we take all of these different pieces and we glue them together to satisfy it. So it's actually easiest to show this with WASI files. Where did you go, WASI? So we have a little script in there if you want to run this on your own. So we'll just build this. And while it's building, it's just building all these little pieces of the actors. And then it will put all of them together. So we'll give that a second because I think I updated Rust. So in the end, what we get is a final actor module or actor component that can be run inside of wasmCloud. And all of those dependencies are injected right when you build it, rather than having to worry about doing it when you're actually writing your code. And in the future, when we get to dynamic linking, all of this stuff where we link it in will just be put in at runtime rather than like beforehand, which is what we're doing right now. Okay, so now we have this component, and I want to show how this all works. So I'm going to go wasm tools, component wit, and I'm actually going to look at actor. So you'll see here that it's like exporting this handler, but it needs this consumer type. So when you write an actor, it's saying, hey, I need to like import this consumer, like I need to use it, and something needs to give it to me. Now, other types of WebAssembly platforms, for them to be able to support this, they would literally have to add this stuff into their host. So they'd have to actually compile a completely new host and run it for them again. In our case, that's not what we're doing. When we compose all this together, the final output actually looks like this. You'll see that there is nothing here. This is magically elided. They're working on actually making that cleaner, so just ignore that for now. But
Taylor,
you'll see.
could you zoom in just a little?
Oh yeah, sorry. Embiggen.
Thank you, thank you.
Okay, bigger. So you'll see here that the only thing we're exporting is wasmCloud bus guest, which is exactly what our host expects to call. And then it imports two things that our host implements for you. Don't have to understand all of it. The net benefit here is all of that stuff about your custom logic and contract is now entirely encapsulated away. And this final module has no knowledge that it's actually doing anything specific with those interfaces, like to the outside world. It's all entirely self-contained. So yes, Brooks, you raised your hand. What do you have as a question before I move on to the next part of the demo?
Thank you. It's me, not Plant. So I just want to be clear with this WASI-fill stuff. This is the implementation of the feature that wasmCloud has now, that you can define your own custom contracts to do whatever you want outside of like the standard contracts that right now we provide. For example, like messaging HTTP. If you wanted to do something super special, like reading off a sensor or like connecting to Bluetooth or just like something new, this is that. And like, as you can see, or yeah, answer that first, I guess. This is that, right?
Yeah, that's exactly what it's for. And another important thing to point out here is you'll see that this stuff is written in Rust, but that actually doesn't matter in the long term. You could write this WASI-fill in any language that can compiles to a component. And once again, you're only writing it once. Before, everyone had to generate one of these kind of libraries for every single language. We generate this once. So this, if this were a real contract, we would say a component written in Go could use this component WASI-fill. If it was written in Python, it can also use this WASI-fill. So essentially what we're doing is making it so you write once, you can write it in whatever language, and then it works for everybody. So for most of our first party ones, because we're already doing it in Rust, we'll write them in Rust. But that doesn't matter to the actual downstream consumer anymore because it's a component. All it has to do is satisfy these interfaces. And you can actually see like all these different parts. Like you can say like, oh, this is, where did it go? Like here's the export component wit, and you'll see that it looks a little bit different, right? Like it's exporting a consumer type. There's all that matters is that those match, that you have an export for every import on your components. And so that's how all of this actually works underneath the hood. But that makes more sense.
Awesome. Yeah, I always want to call, special attention that this is the implementation for contracts. You're, developing you're developing a new contract or a new feature. But all of this whole pipeline with WASI fills and things like that doesn't come into play when you're using the standard interfaces for things like wasmCloud and like those imports and exports we can't actually predict on wasmCloud's side. Is that, I guess that's a statement,
correct, yeah.
but also
that is a statement, but it is true. It is a true statement, Brooks. The wasmCloud stuff is automatically provided by our host, and it's actually doing this kind of stuff underneath the hood to translate it into lattice calls. But you don't have to do anything for that one. But for custom components, you'll need to do things like this. So
cool.
It looks like Jordan had a question.
Yeah, I'm just curious. I'm just curious to understand the relationship between the specification here and the packages that I'm supposed to be installing as part of my dependencies, and how that's supposed to work more or less.
Yeah. So how this works is inside of your the actor is the only thing you'll ever touch, which is in most cases, which is what I'm going to get to next. But your actor has WIT dependencies. And these WIT dependencies right now are with a simple tool called WIT deps. I have messaging here embedded inside of a directory, but this is also like a URL or whatever that has the contract location. And then that's all the dependencies it needs. So that's what specifies the dependencies for like which contract it's doing. And then inside of the code, this is taking those dependencies and saying, hey, I'm going to generate the bindings for this for you.
Yeah, so no more Rust dependencies myself. Is more in the WIT level, and the WIT component is supposed to figure out how to resolve the dependencies and whatnot. Is that correct?
Yeah, and it generates all those code for those dependencies. So dependencies approach a different thing because they're now behind interfaces. So normally this is something that's core to wasmCloud as well. Like the whole reason why we created wasmCloud is you used to have this thing, right, where okay, I'm importing Redis, right? Like, and you had to choose Redis and you had your Redis client embedded. In this case, you're just saying I am making a call, but I don't really care what's on the other end. I just care that it satisfies that interface. And so that's what you're doing when you're going and coding against dependencies, is you're going against dependent contracts. You can still pull in dependencies, like you can pull in serialization stuff or like processing logic, other things that you could pull in like that are specific to like Rust or to Go or to whatever language you're using. But these like key pieces of things are done by contract. Yeah, and Bailey pointed out this should be able to swap over to cargo component when that's all working for us. It's the same thing. So.
All right, Taylor. All right, so let me just explain it like Liam, which the team jokingly, uses as the lowest bar the hurdle to get over here. So we start with I want to create my own component in JavaScript or in Rust or in Go, and I'm going to use the tooling that's going to make a portable Lego block that runs everywhere. Is that right? Just take me through it one step at a time. Okay, and then I would want to be able to upgrade this into all of the things that wasmCloud does. So what this WasmFill is essentially like a harness that will automatically take that custom component and then give it all of the extra features that wasmCloud provides automatically, and then enable things like distributed access and all of those other features, correct?
Yes. So essentially, the nice thing about this is, once again, it is entirely platform agnostic, because there's no, like in this case, this is a wasmCloud messaging contract because I was using it as an example. But if I was writing my like GPIO contract, that can now mean that anything that can implement that contract, I can use my code with, but I can also use it with wasmCloud because I have these like scaffolding things that go in.
Okay,
so
that's a great example. Let me just repeat that. So I have like my Raspberry Pi here. Mm-hmm. And it's got all these little GPIOs, hanging off it and off the top here. And so I want to be able to, program or use this GPO component from over here on a remote wasmCloud host. This is on my edge, say, but I want to have my business logic running in the cloud. Once I've taken the standard GPI component, I upgrade it with the wasmFill. Now I could access it from the cloud, right? Or from anywhere.
Yes.
I get all the stuff that wasmCloud gets. I get it for free. So this is stupid powerful because it lets you take standard components, which are the portable atomic building blocks that should work on all wasmCloud places, or I'm sorry, on all WebAssembly runtimes, and it gives you the application features that the wasmCloud application host gives you. Is that right?
Yes.
Okay, thank you for just walking through it at a real elementary level.
Yeah. So the other thing I want to point out here is we don't want people having to manually write these that often. You only have to really write them once, but we're going to be doing tooling that you can basically say, here's where my wasmFill is at, pull it, put it together for him, but we're also going to generate them. And that's the other thing I wanted to show that I'm halfway through at this point. So rather than hand rolling all this code, we can actually generate it. And this is kind of what it's going to look like. I'm going to generate it by wash, and it's actually going to look for like this thing at the top, so you can modify it to your own use cases. But what happens is that as I take this, I actually parse the wit, and then I spit out a file. So I can actually show you like by running that over here. wasmFill gen Argo. So that generated a file called wasmFill export.rs. You just go back down to a single pane, if I remember how to do that. And you'll see that it actually generated code for me from my WIT interface. So that's this is generating that export thing. And all of this code is now automatically generated for you. It does. So basically, you'll get a wasmFill for free. Now, if you're an advanced user, like let's say, I know there's some companies that have like data encryption requirements. We just use our default, like we encode it to message pack in this case. That's the default for a lot of things inside of wasmCloud. But let's say you were encrypting this. You could encrypt the data inside of here. All that matters is you basically have a vec of bytes that you send out to the host. And so we'll have documentation on this, but you can modify this and change it to do whatever you want. Or the default use case for most people will be Wash generates this for you when you create a new interface. You push it up, you publish the wasmFill, and you're good to go. That's pretty much all that it will require. So this is just one side of it. I have to do one more wasmFill part of this, and then do all the other automatic things. But this is generating. So like I said, this code right here is purely generated by the thing I just ran, parsing my WIT, which is the exact same WIT I was using for my wasmFill exports. And so this should all be able to be generated for you automatically. That's the current plan. So I was showing you all that. I showed the complicated thing, so everyone knew what was going on and why we were doing it. But basically, as most users of wasmCloud, all you're going to do is basically wash new interface, and then you'll say like wash generate, and it'll generate this code for you, and then you can just push up your wasmFills for it, and it'll just be ready to go. So obviously, we're starting with just Rust to automatically generate, but as you saw, this is just handlebars. So you could do this exact same thing with Go or with Python or whatever we wanted to do. We'll obviously take any contributions will be welcome once we get this rolled out and working, but you can basically have it set up to build for build or generate a wasmFill for every single language. So that's, like I said, started complicated, then said, guess what? You're not actually going to have to worry about this in most cases, which is the real goal here. So this should be done mostly automatically for you in the future. And basically makes it so you can add whatever types of extensions and via contract that you want to on top of wasmCloud. So whatever your custom use cases are, whether it be your own custom project you're doing or something for work, can be done through this way. Any questions?
So, sorry, I may miss it, but just to recap, like when you compile it, those dependencies are injected not at the host level, right? But your component, you're just hiding away a little bit the wiring, right?
Yeah, so they're not at the level of the code you write. So that means that if there's a bug, especially when we get to dynamic linking, we could hot swap it out so that you don't even have, like, if there's a bug in the wasmfill code, you can swap that out really easy.
Right. Yes,
But like
that is
all
not at the host.
yeah, it's not at the host
Yeah.
level, but like
Okay.
all I'm doing to put this together is here, let me actually expand this out a little bit. All I'm doing to compose it is I'm like putting all the modules together. Like I'm taking the actor and I'm putting it together with the export and then with the import and then with the multiplexer, which is something else I didn't really talk about today. And then it just generates it all into that final composed component.wasm. So that's like what's actually happening when you put it all together. So the components are still entirely separate from each other. They just get, as we jokingly call it, smushed together when you compose them. Vance, you had a question?
Yeah, I don't want to take up too much more time. I'm trying to understand some of the details of it. But the first question was, you do all of this in an interface project, right? So
Yeah.
I've got an interface project which uses Smithy today. I can rewrite that in WIT. And then I'm not clear on, is it generating Rust libraries that I can use in my actor Rust projects, or is it generating a component that is linked with the component that I generate from my actor? And if the latter, is that linking done statically or is it done at runtime?
Yeah, so right now, so WIT bindgen generates code that can be used as modules inside of your Rust code or Go or whatever that's what WIT bindgen does. The component part of it, those things are, that compose thing I was showing you is basically a static linking step. That will be have the possibility of being dynamic here in the future. Right now, it's just static. So we glue together the components. You can actually, I don't know if they have the tooling for this, but you can technically explode those components back out if you want to. But in this case, like we're statically linking it to a like final, this is the actor I'm going to run. And then from there, like that's where it can actually do the full like run in wasmCloud, do all those steps. So it is statically linked for now. We will hopefully have dynamic linking as soon as that's supported within the component model, which is definitely planned as far as I know.
It's effectively the same as today. And when can I use this?
Hopefully, I'm trying to get it done by the end of next week. There's a lot of little like loose ends to tie off with this because I have to generate a couple different things, but this should be able to be done in the next 2 to 3 weeks is what I'm hoping on here with the wasm.
Oh, okay, great, thank you.
Okay, there we go.
All right, thank you, Taylor. I'm super excited to see that come along. I think we'll just keep, not saying there's going to be the demo every week, but we'll obviously be super transparent about when we're moving, our regular examples and things over to use the WASI fills or standard contracts, things like that. All right. Well, I know that we've got about 25 minutes left, and we do have a good bit of discussion left. So I'm going to propose that we go ahead and move on. I did queue up one long form discussion that doesn't relate to an RFC, and then I wanted to bring up two of our RFCs that are out there. One was called out last week, and the other one is new as of maybe like an hour ago. So it's more of a call to, well, whatever, request for comment, for people to go look at it and say what you think. But the first one that I wanted to talk about came out of a discussion in the wasmCloud Slack with a wasmCloud member named Nikita, which I can't, unless I'm getting any names wrong, I can't see if they're actually here. But so speak up if you are, but I might be missing something on Zoom. But what I really want to talk about is the RPC timeout that we have in wasmCloud today. So you may or may not know, wasmCloud operates off of this very special timeout that you can configure at runtime for a wasmCloud host, where whatever value you set, that is how long wasmCloud will allow a certain chain, a certain operation to execute for. This is kind of a nested timeout. So as soon as, if you're doing something like receiving an HTTP request, sending out a message, and then operating on a key value store, and then operating on a SQL store, and then you return that 2000 milliseconds or 2 seconds is the entire amount of time that that's allowed to operate. The reason why, just generally, is wasmCloud is a distributed system. Everything can run on one machine, or it can run across many different machines. And it's actually really hard to tell if an operation is taking a long time because it's timing out, as in it can take an arbitrary amount of time to execute, versus a process that will never finish because it's made some request to some resource that is never going to return, right? When you have something that can take, something on the order of magnitude, say you're downloading a file, right? That is something that can take an arbitrary amount of time, depending on network conditions, how big the file is, things like that. Just a general heuristic there. So we limit these types of executions. We prevent infinite timeouts by providing, kind of a kill switch here in this timeout. This is actually, I noted this is good pre-reading, the Dealing with the Diabolical Distributed Deadline Dilemma blog by Kevin. Kevin's Distributed Systems Master. He's got some really awesome thoughts on it in this one. I would definitely recommend it. And this has kind of inspired some of my thoughts for today. Talks about kind of the problems of trying to solve a deadline, like trying to limit a process to a certain amount of time, or just letting it go free in a distributed system. Now, there are a couple solutions proposed in this blog. Some of them talk about, like, the overarching solution is to not have this problem in the first place. Obviously, it's a little tongue-in-cheek, but talking about architecting your application in a way that you're not sending out a request that waits forever. But the real thing that I want to focus on in this discussion is just talking about the viability and the use case of long-running processes in the first place. I think we've all kind of generally seen that WebAssembly works really, really well for like functions as a service, like serverless style invocations, where you send it some information, the WebAssembly module does some processing over not too long a period of time, and then it returns. And if you look at different serverless frameworks, they solve this in a couple of different ways. I think one of the biggest examples or one of the most popular examples is AWS Lambda. And Lambda has a built-in default timeout of 15 minutes, where you can't execute for longer than that. And that is, of course, they're assuming that you're doing processing the whole time. So I really hope to have an example use case to kind of build up this straw man around. But one thing that we don't really encourage or have a lot of examples for right now are wasmCloud actors that are doing long-running processing, long-running computation, and it just doesn't fit exactly into the model that we put out a lot of our examples for today. So I'll pause. I'm curious if folks have thoughts on this particular topic. I've got some things that we could continue to talk about, but we'll go from there. Yeah, Jordis.
So is that just the default timeout, but I'm able to control it?
Yep, exactly.
Okay.
I think it's worth advanced.
But per client, right? Per call, sorry. Just to make sure.
It is per call, but it's not accumulating. So it's like the overall timeout. Mm-hmm. So like this sequence diagram, for example, this isn't wasmCloud specific or anything, but right at the top level, when you initiate that invocation, the process all the way down the call stack in the system in wasmCloud, that starts your RPC timeout. And further down the line, it technically starts the same RPC timeout over and over for that like sub process, mm-hmm. but at the top level first.
Yeah, I think that totally makes sense though. As long as in every single these services call like side effects, I actually could say, hey, this is how my SLA for this timeout is.
Yeah. It is at the host level though, and not at the specific application level. So if you have one set of actors and providers that form an application that you always expect to, to execute within a couple of, a couple hundred milliseconds, and you have one other process that you expect to, work within the order of a couple of seconds. You either have to set that blanket RPC timeout at the higher end for all of them, or you have to run it on a different host. But you have to be careful, because if you go between hosts, that might be working with different RPC timeouts.
Personally, from the architecture perspective, I do need per client control over the timeout though. Otherwise, you're already making architectural decision and assumptions that it may not fit the problems that I'm facing. So I think when it comes to this thing, is one of those where like give the capability to somebody to control it, trying to put sensitive defaults so they don't shoot themselves in the foot, or at the very least you control a little bit, like people forgetting about it. But you have to give access to people to control the timeout per every single side effects. Otherwise, yeah, I don't know. That's my take on it.
Okay. Yeah. Like to hear that. Vance, I thought I saw you raise your hand, but I wasn't sure if that was left over or kind of.
Well, I mean, it comes to mind that I brought a similar issue up a few weeks ago when we were talking about REST pagination. But I guess it's not the same issue. But in general, I do think that we probably want to loosen the restrictions on the ephemerality, if that is a word, of vectors. I think it would be nice if you could start an actor and have it not necessarily go away when it responds to the first request, but hang around and then time out if it doesn't get another request. But that I'd be maybe opening up a whole can of worms with that. In fact, the REST problem I ended up solving with a design that involved a special capability provider anyway. So
yeah, I think that's been some of our guidance leading up to this point. If you want to do long running processing, then you can push that into a capability provider because it can continue to execute. I think it works well, and I don't know if it's the best answer forever, just because I think people are going to want to write stuff, compile it to WebAssembly, and do their processing there without opening the whole can of worms of where providers are going with all that.
Yeah, my thing that I started with this was coming around, like I wrote an image resizer for my own like profit, joy and profit. And the problem was the bigger the image gets, the longer it takes. And I can invent something, right? Like I could hook up my actor to like, I could externalize part of it to a provider that would make sure like it would alert when something was done. But what I would really like, I don't know what this looks like. I don't have an idea yet, but what I would hope I could do is to have some sort of easy to use mechanism that says, hey, request, I'm going to run for a little bit longer. You just keep doing you, and I'll trigger something like, here's a handle you can call back to and see if it's done. Or, like, here's an event I'm going to send you. Because I don't want everyone to have to reinvent that wheel every single time they want to do something similar. And so I wish there was a way that we could like say like, hey, just leave me running. I might run for another 10, 20, maybe 120 seconds, who knows, but like leave me alone over here and I'll get back to you with the result of this operation. If I can find some way to do that, that would make me very happy for those use cases. So that like, if we can design something that fits kind of around that, that'd be really interesting, but I don't have an idea yet.
Yeah, I mean, that's what I would like to have from the architecture perspective, right? And you already have the NATs under you. So, if me as a client, let's say you're a worker that is organizing paper, I may decide in any situation if I want to be waiting 5 seconds, or I don't have time, I need to move on right now, or I can just sit here for the next 5 minutes for you to finish to organize the paper. The way I would architect it is that you would send a message back to whoever is interested to say, hey, I'm done with the papers. So it's my responsibility to be listening to those messages and say, yeah, I care about that. Let me now continue doing it. And from the code perspective, you know, all you want is just simple SDKs that says, hey, I'm interested in this message. I know Nat's request replies does that for you. You know, it wraps everything so you don't see the blocking until you receive the message or whatnot. Go ahead, Leon. I don't know.
I think if we look at the queue here, Dave, you're up.
Dave's next.
Okay, sure. Yeah, I mean, ideally everything's fire and forget, in which case you really don't have that problem. But what I would really like to see is if something like that was built into the host such that there was some sort of training and machine learning ability. So it monitors actors and says, okay, the typical timeout of this particular actor under these conditions is this. And so therefore I'll only report something if we start going out of a, you know, some preset kind of, you know, guardrails that says, well, normally this thing takes 2 seconds. So therefore that's what I'm going to do. Training period over. We're good. We're running in production. And then if it starts straying out of that, only then it might start, you know, warning the system or something like that. So basically exporting that whole problem into another component, another module or something like that. So the individual app does not have to deal with it would be wonderful.
Taylor, maybe you and I have a little sidebar here in DM on the roadmap stuff. And the comment that I wanted to make is, you know, one of the gaps in WebAssembly at the moment that we're working towards, you know, this is, you know, we're right, you know, here now or something like that. And then a little bit later this year, we hit the finalization of WASI Preview 2. And at that point, you know, things will stabilize, all the runtimes and the language tooling. We're going from there. And maybe, Taylor, you could link this blog post, but underneath the hood right now, you know, WebAssembly doesn't have, you know, async support. And what that will enable is futures and streams. And now how that manifests itself inside of wasmCloud is a bit different. And maybe that's where, oh, Bale, you don't think this was really relevant at all? You can jump in. Go ahead.
I mean, it's really cool. But I would say that the async behavior within WebAssembly components is relevant in intra-component in that you've composed with other pieces and parts of your component. And so you're able to write different types of code when you're composed with others. So it would be really relevant actually to maybe even the WASI part that Taylor was showing off, because that's a composed component. But with wasmCloud and our SDK, that async behavior is actually handled by our wasmCloud host. So we have basically all of these features and functions that we really want the WASI Preview 2 stability. That is totally a worthwhile thing to call out. But we perhaps aren't blocked on async being available by the component model.
Okay, great.
You said streams though, and it did make me think. Another possible workaround here, this is not WebAssembly streams, those are good too, but maybe we should have the idea of a stream inside of wasmCloud, because then you can give that pattern of like, hey, this is like streaming data, so I'm sending something and I'm expecting something to be sent back. And so like it's like basically a bi-directional stream. Like I can send something up, I can receive something back, and then we can do that kind of stream pattern of processing data. Like, hey, do you have something for me yet? Hey, do you have something for me yet? It can be one of the patterns, or it can be like, I'm just listening for a message on that stream. As soon as I get a message, then I've got the data back. Anyway, really rough idea I just thought of, so it could be totally wrong, but if that's one possibility I was just thinking of there.
Yeah, one thing at the infrastructure level, you could put, the notion of the correlation ID, so you could simplify more or less what message you may be interested. Taylor, one thing, instead of thinking about, hey, I want to receive a message from this particular queue, I think you have to, like me as a client, I have to know that Bailey is the one who's doing the work. Therefore, I need to be subscribed to Bailey's queues to figure out if I want to continue or not. It's just I need to be aware of that she's going to put enough information in those queues or the messages for me to understand if the work I request from her was done or not, or if I should move on and whatnot. Because otherwise, Bailey would have ended up being responsible to understand everybody around that communicates to her. But me as a client, I already know I have to communicate with her. So it's my responsibility to understand, hey, what messages she's producing or what not, and what should I do about it? And now with that correlation ID is important, because if I pass an ID, the correlation ID that you pass through all the messages, I can say this given message is because of the workflow that I initiate in next given point in time. Therefore, it's related to the task that I ask you to do. And then you move on. That's how I've done it before when it comes to all this message passing.
Yeah, a streaming thing will be interesting, because this is where we get into the desire for wasmCloud has always been to be as platform agnostic as possible. But when you start doing something like a stream, that means it's something that's very wasmCloud specific that the code would have to know about. We might be able to find a way to kind of abstract it away somewhat, but like the code will have to know about that. And so what I'm trying to think of is balancing the like, okay, you are you're trying to keep it as agnostic and portable as possible, because right now, like as I showed today with like the wasmfill stuff, if you write something for us to run in wasmCloud, all that you need is the wasmfills. Your code could technically go run somewhere else as long as you have that same like contract support. And I know we have streams inside of WIT, right? So we'd have to represent most of the contracts like purely through streams and maybe hook it up that way. I like that. That was my thinking, Bailey, like when I was thinking actual implementation details. But it would also mean that like contracts would have to reflect that, right? So like some things that might not be, so like an HTTP service, right, is expecting eventually like an HTTP request. And so, yeah, it's the contract reflecting it. So like, I'm just hoping that like, I just imagine there's going to be contracts that don't necessarily have streams, that don't make sense with a lot of streams. And then if they want to take advantage of something with like longer running stuff inside of wasmCloud, then they'd have to have a separate version, which isn't the worst thing in the world, but have a separate version of the contract that's more stream focused. Yeah, that's just, I don't know, thinking out loud here.
Yeah, what I was going to say is that pull one off and all of the kind of some of the ways that you would expect the actor written as a WebAssembly component hitting the WASI-IO streams. And then eventually we're going to have a type that is stream. But right now we're able to describe the APIs that you would expect of a stream, including getting a pulled list that the host can then implement back buffering on. And so within our host implementation, underneath, I would expect us to implement something like NAT streams for the underlying actual implementation for this, but it seems like the modeling is well-defined. So I think this is probably how we would want to start defining contracts. We don't yet have support for this, but I think we should.
Yeah, I think a path forward here would be as soon as streams are stabilized inside of WASI, I think then we say like, hey, anyone who wants to, like, it can be one of the core maintainers, it can be anyone in the community, just like, I'm going to spike this. Let me just see what it looks like. And we can use that as a basis for an RFC, because right now I don't think we have enough knowledge to be able to say, this is what it's going to look like, and this is how it's going to work. I think we're going to need some spiking once it lands for this to actually be something we can then say, okay, community, here's what we think could happen. You know, like as we all come together and say, we tried this, we've done it this way, we've done it this way, like what are the trade-offs, and then have some sort of good solution in place for people to do that. So I think basically it's like the outcome of this would be, we're going to wait for a couple months and then we're going to, as soon as we have streams land, then we can try to Yeah, that's what I was thinking. Exactly. Like as soon as we get like the preview 2 streams like solidified, it'll just keep getting better from there is the idea. But I think we'll have to wait for preview 2 streams to solidify in the next 2 months or so. And then we can try doing it.
Roman's working on the adapter part for that right now. So we're helping upstream that work. So we're not just waiting, we're getting it done.
Anyway, I would think like, so does that sound like a good place to leave this for people? Like, hey, we'll get as soon as streams are in, we start just trying to experiment and see which looks the best, and then kind of come up with an RFC from there.
And to be clear, we're thinking that actually implementing streams will give us the ability to have something that's like to have a legitimate long-running wasmCloud process. Like in my actor logic, I want to do a computation that takes 10 minutes, and that's a possible thing.
Yeah, that's what I'd say. If you have an open, like I want it to last as long as the stream is open, is the
Gotcha.
reductive version of it. Like we smash it down.
I think that sounds pretty reasonable. I've been considering whether or not we want to use GitHub discussions a little bit more. But I think we talked it out pretty well. And I think this probably would be a good thing to add in the it can be a discussion, or it can be an issue that we put on the later section of the roadmap. Up to you on how you want.
I think that part convinced me we should make it an issue, because I want, like, it's just going to be mostly call it out as a placeholder, but that way we know where it's at, and then as soon as preview 2 like stabilizes, we can start experimenting with it. And like I said, if anyone wants to be like real bold and just try it with what's there right now, feel free, and you will have the coveted, as Brooks called it, demo slot guaranteed to talk about it and show it off. So anyway, that if you want to try it, but I'm gonna say, like, just with how much we're trying to finish and stabilize, like the WASI fills and the provider SDK stuff and everything that's going on, like it'll probably be best to pick it up when WASI preview 2 stabilizes from the core maintainer perspective. But anyone in the community, because I know there's a lot of the interested parties here, you're completely welcome to try this and ask as many questions and crazy things that you want to try out, because we're all good with that.
And to be clear, if you were to build something, you would want to use the pull request that I sent that uses resources. That changes a lot of the way that these underlying interface definitions work. But I will say, as far as we know right now, this is it, TM, for the thing that we're planning on standardizing. So when we say land, what we're talking about is, first, we've got to get all the interfaces that depend on this piece, right? Because streams is a fundamental underlying piece, and we've built a lot of things on top of it, like WASI HTTP. So WASI HTTP needs to point to the new thing, the WIT parser, WIT syntax, WASM time, all of those different pieces that happen within the bytecode alliance have to land it, and then we would consume that within wasmCloud. But there's nothing stopping you from entering the fray here.
Awesome. I think that sounds great. Throwing it in the later section of our roadmap is kind of where I propose we put anything that needs additional spiking, has external dependencies, things that we can't reasonably prioritize for right now. Unless you do it based off of Bailey's PR, then you can DM me anytime up to 12:59 p.m. Eastern time on a Wednesday, and you can do the demo. Dan's PR. Okay, we have 0 minutes left. So if anybody has to jump, thank you so much for coming. I think we'll keep this part of the discussion pretty light. It's really just an additional call out. We have we have a couple of open RFCs, but we have 2 recent soon to be considered RFCs to accept One is around metrics, which Patrick wrote up and contributed, which is awesome. We talked a little bit about this in the call last week, but there's been some good discussion here on the issue. I won't read out all of it because there's a lot of words, but please go take a look at that. We're talking about implementing Prometheus metrics in wasmCloud, some of the things that should be instrumented as metrics, things like that. And then I actually just put in an RFC this morning that we've been talking about for a little bit, but we haven't really gotten to execute on until now that we have WASM time and instantiating precompiled components and modules, which is super awesome. This RFC talks about the ability for wasmCloud to auto scale based on request load and effectively scale to zero when not in use. Scale to zero specifically referring to the fact that you can start an actor when it's not actively executing, it's not taking up CPU or memory use resources passively at all on the host. We have something close to this today. This RFC outlines a little bit more about what we do with having a set of instances or a list of instances, and all of this is proposing renaming the count. The core of this RFC is renaming the count field to a sort of like max scale, max instances, max concurrent, something like that. So you can effectively bound the upper limit of concurrent execution on a single actor. So would definitely value some thoughts on this one. I tried to go really in depth on some of the things that we can change in a backwards compatible way to not break things. I think it'd be really nice if we do everything right. I think that this can all go through with the next minor bump in wasmCloud without breaking existing scripts and things like that. But yeah, this one is open as of, like I said, an hour ago. It's just pre-community call, so I don't expect anyone to have read this yet, but it's open for comments now. I think I've got another couple of minutes to hang out for a second. If anybody had any initial thoughts on either of these RFCs, I think go ahead and throw them out now. Yeah, you had a question, which is kind of interesting. You're asking about keeping an actor kind of hot and running ahead of time. This is essentially why we had instances running beforehand. I'm actually taking the stance that we don't even need to support that use case. And let me tell you why. WebAssembly is pretty fast. It's really quick to instantiate. Like the cold start penalty of keeping an actor or of not keeping an actor hot is in like the single digit microsecond level of latency, as long as you are performing the right optimizations, which us, of course, as a host runtime will be responsible for. But I see very little tangible benefit to keeping an actor hot, which is actually really, really cool. And I hope you're getting some of like the excitement, sarcasm in this. I'm not shooting down your idea, but I'm looking forward to coming out with some numbers there, because it's really just core WebAssembly. It may be something that the very first instantiation takes like just a little slightly longer. Like when you start the actor, we do the precompile step and all that. But the really cool thing about this, especially in the lens of how long a thing can be executing, WebAssembly is so fast to instantiate and get started on work that we don't need to consider running hot instances, which is pretty cool. And I'll just leave it at that. All right, well, I think that's a good time as any to wrap up the stream. Thank you all for coming. Anybody who's watching live, appreciate you watching. And for our 2 new community members who are on the call today, thank you so much. Everyone is welcome on this community call to come and join in the discussion or just lurk and hang out. But other than that, I think we'll go ahead and stop it here, and we'll see you all next week.
Thanks all.
See you.